Okay, so this is a key on the topic 19 on radicals, and this is called worksheet extra number 5. Now, you want to simplify each radical. It says assume that all variables represent positive numbers, so you don't have to worry about any absolute value notation at all. That's what that means. And then show all required work to receive full credit. All right, so if we look at number 1, so number 1, we have the square root of 32x to the 6. All right, so notice that 32 is not a perfect square. We're dealing with square root. 32 is not a perfect square, so I know I have some work to do. Also notice, though, that the exponent here is divisible by 2, so that's going to be easy part right here. Now, what I would do first is I would write this as a product. So using a product rule for radicals. So it becomes the square root of 32 times the square root of x to the 6. Okay? All right, now let's talk about the square root of 32. The largest perfect square that goes into 32 is 16 because I'm sorry, yeah, 16, right? So I get the square root of 16 times 2, okay, because 16 times 2 is 32. And then notice this right here. So I have the square root. I didn't write this symbol very well, but I have the square root of x to the 6. And so you ask yourself, what times itself twice is x to the 6? So you learned that in a previous lesson, and there were worksheets on that you dealt with. So since 6 is divisible by 2, we know the answer is just x cubed. 6 divided by 2 is 3, because x cubed times x cubed is x to the 6. Now let's talk about this. So you learned this part in the previous lesson as well. So I'm going to rewrite this as the square root of 16 times the square root of 2 times x cubed. And the square root of 16 is 4, so this becomes 4 square root of 2 times x cubed. All right, so you can leave your answer like this, okay? You can write your answer like this, or if you want to, you can put the square root, the radical, on the end. So in other words, you can write this as 4x cubed square root of 2. It does not matter, because remember, multiplication is commutative. The order in which you multiply does not matter. All right, but usually you'll see in this case, sometimes you'll see textbooks that have the variable part written at the end, and sometimes you'll have the radical part written at the end. Just wanted you to know that it did not matter which one you wrote. Okay, but there's your work. That's your work. And then that will be one of your answers. All right, now let's look at number 2. Number 2, I have the square root of x to the 19. Okay, now that one's not as simple as this one was, because 6 was divisible by 2. Here, 19 is not divisible by 2. All right, now remember what you got to remember. So a radical can be simplified if the exponent that you see is greater than or equal to the index. So notice 19 is greater than or equal to 2. So I can simplify this. And listen to the way we did that. So if you recall our lessons, this is what we did. So you want to rewrite this. You want to rewrite this as a product. You want to rewrite x to the 19th as a product of two factors of x. So, and remember, when you multiply like bases, you add exponents, such that the exponents add up to be 19, and you want the largest to be, since this is 2, you want the largest to be the largest integer less than 19 that's divisible by 2. So in other words, 18. So 18, and then this will be x to the first. 18 plus 1 is 19. And then notice, just like we did here, 6 divided by 2, we get x cubed. 18 is divisible by 2. And so now this becomes the square root of x to the 18th times the square root of x, and the square root of x to the 18th. So what times itself twice is x to the 18th? Well, 18 divided by 2 is 9, so the answer is x to the 9th. So x to the 9th, square root of x. Okay? All right, now I just want to remind you something. So someone else may have, instead of using x to the 18th, I just want to show you, you can get the same answer, but it's always easiest to use you see how many steps? It's not a lot of steps. It's always easiest to use the largest exponent that's less than that's divisible by the index. So example, someone else could have done this, just to remind you. Someone else could have said, well, I'm going to write this as the square root of x to the 10th times x to the 9th. Okay. That's true. 10 plus 9 is 19, right? And then 10 is divisible by 2. No issue with that. There are multiple things you could have said here. And so then this becomes the square root of x to the 10th times the square root of x to the 9th. And then the square root of x to the 10th, what times itself twice is x to the 10th? Well, 10 divided by 2 is 5, so that has to be x to the 5th, square root of x to the 9th. But you're not done. Because remember, a radical is simplified. You can simplify a radical if the exponent is greater than or equal to the index, and it still is. See that? So then you may say, okay, I gotta work with this even more now. Okay, that's true. So you get x to the 5th, and you may want to say, all right, I'm going to use x to the 6th. Let's say I'm making this up. Okay, x to the 6th times x to the 3rd. Y'all agree that 6 plus 3 is 9? All right, so then you can go further, right? Well, that'll be x to the 5th times the square root of x to the 6th times the square root of x cubed. But you see how many steps you're doing? There are a lot of steps, right? Whereas if you just had used the largest to begin with, you would have saved yourself a whole lot of time. And so then this becomes 6 divided by 2 is 3, so the square root of x cubed is x, I'm sorry, the square root of x to the 6th is x cubed, so this becomes x to the 5th times x cubed times the square root of x cubed. But then you got to notice I can simplify this further, and so then this becomes x to the 5th times x cubed times the square root of x squared times x, and then so I get x to the 5th, x cubed times the square root of x squared times the square root of x, and the square root of x squared is x, so this becomes x to the 5th, x cubed times x times the square root of x. And then now you see this right here? I can simplify this. I can write it as 1 because I'm multiplying like bases, so I add exponents. X to the 5th times x cubed times x. 5 plus 3 plus 1 is 9. So I get x to the 9th, square root of x. And notice that's the answer. See how many steps you took? Whereas if I had just done it the largest to begin with, I would have gotten the answer right away. Okay? So that's why in the lessons we always indicated use the largest exponent, the largest number that's less than 19 in this case, that's divisible by the index. All right, so you see you save yourself a whole lot of steps. Okay, so that's what we're going to use from now on in this key. All right, number 3, you have the square root of 100, x to the 11th. All right, so that's going to be see the square root of 100, that's going to be the easy one. This not so easy because 11 is not divisible by 2. But we're going to use this idea we did here. So using a product rule, this becomes the square root of 100 times the square root of x to the 11th. The square root of 100 is 10 because 10 times 10 is 100. And then for this one, think about what we said. See, that's square root, so the index is 2. What's the largest number less than 11 that's divisible by 2? The answer is 10. So that's x to the 10th times x. And always check, x to the 10th times x to the 1st is x to the 11th. Now using a product rule, this becomes 10 times the square root of x to the 10th times the square root of x. And now x to the square root of x to the 10th is x to the 5th, because x to the 5th times x to the 5th is x to the 10th. So you get 10 x to the 5th square root of x. And remember, you can just say 10 divided by 2 is 5. And so there's your answer there. All right. Now you see how in this case you have two factors with variable expressions. We always put the square root of, if there's a variable under the square root, we always put that at the end. See, it looks better. See how it looks better here? Now you could have said this if you wanted to. I have no issue with that. You could have said that, but this looks like better, right? This answer looks better. Okay? But either one's fine because multiplication is commutative. The order in which you multiply does not matter. But we always put the factor that's the number in front. All right, so you see how we have 4 in front. Here the number was 1, we don't put it, and here it's 10. Okay? All right, number 4. Number 4, we have the square root of 8m to the 8. So using the quotient rule, I can write this as the square root of 8 divided by the square root of m to the 8. And so notice this one's the easy one in the denominator because this is 8 and 8 is divisible by 2. So my denominator becomes m to the 4th, right? 8 divided by 2 is 4, and it makes sense because m to the fourth times m to the fourth is m to the 8th. Now, this is 8's not a perfect square, so what's the largest perfect square that goes into 8? So that'll be 4. So it becomes the square root of 4 times the square root of 2. And so the square root of 4 is 2, so the answer is 2 square root of 2 divided by m to the fourth. All right, there was only one way to write it, and there it is. Okay, so that was number 4. Number 5, we have the square root of x to the 17th, y to the 20th. The square root of x to the 17th, y to the 20th. Okay, so using the product rule, but before we do that, notice that the 20 is the easy one because 20 is divisible by 2, 17 is not. All right, so let's use the product rule. I get square root of x to the 17th times the square root of y to the 20th. Now, think about simplifying this. Remember, we can simplify both because 17 is greater than or equal to 2, so you can simplify that. Notice I couldn't go any further here because the exponent of 1 is less than 2. All right, and so I can simplify this further. So what's the largest number less than 17 that's divisible by 2? The answer is 16, right? So I'm going to rewrite this as the square root of x is 16 times x. And then I'm going to go ahead and rewrite this. That's going to be y to the 20 divided by 2 is 10. So y to the 10th. All right, because y to the 10th times itself is y to the 20th. All right, let's rewrite this now using a product rule. I get the square root of x to the 16th times the square root of x, y to the 10th. Okay. The square root of x to the 16th, 16 divided by 2 is 8 now. So this becomes x to the 8th, square root of x, y to the 10th. All right, now let me remind you how we tend to write this. We don't write it like this, although that's an acceptable answer. This is an acceptable answer. Acceptable answer. Remember our discussion? Whenever there are multiple variables involved, we tend to put the variable, the radical expression on the end. Same thing here. You see that? So we're going to put this on the end. So this becomes x to the 8th, y to the 10th, square root of x. All right. So either one is fine. So this would be the preferred answer. Okay. All right. See how the variable expression at the end. Okay, but it doesn't matter. Okay, but as long as you simplify this, it does not matter. This is preferred. Okay, let's look at number 6. So number 6, we have this for number 6. We have the square root. We have the square root of x times y to the 11th. Square root of x times y to the 11th. Okay, so according to the product rule, I can rewrite this as square root of x times square root of y to the 11th. Now I want you to notice something. I cannot simplify the square root of x because the exponent is 1. 1's less than the index. So I can't do anything else to that. But I can simplify this one because 11 is greater than or equal to 2, the index. So what is the largest perfect square, the largest number less than 11 that's divisible by 2? And the answer is 10. So I'm going to rewrite this as the square root of x times the square root of y to the 10th times y. Now I'm going to rewrite this as a product now. So I'm going to rewrite this as the square root of x times the square root of y to the 10th times the square root of y. Now I can simplify the square root of y to the 10th. That will be y to the 5th. So I get the square root of x times y to the 5th, right? 5th times the square root of y. Okay, now remember our property. So you got to remember this because you cannot leave your answer like this. You're not going to get full credit. You'll get most of it. You won't get all of it because you got to remember this. If I have the a root of b times the a root of c, as long as the indices are the same, the indexes are the same, I can write this as one radical. So it'll be the a root of b times c. So notice that this right here and this right here, the index are both 2. So I need for you to use this property. So that becomes y to the 5th times the square root of xy. So that's the answer. Okay, if you leave it like this, you don't get full credit. You gotta remember You already know some information about this idea here, so you got to use it. Square root of x times square root of y is the square root of xy. Now, you could have also, if you wanted to, remember how we said we tend to put the radical, um, the expression at the end if you have variables in several places. You could have said this if you wanted to, but this is preferred right here. You could have said the square root of xy times y to the fifth. All right, but this doesn't look as good as this one does. All right, so that's the preferred answer right here. So this is preferred. All right. Okay, let's look at number 7. Okay, number 7, you have the square root of 28 x to the 9th, y to the 12th. Okay, so the square root of 28 x to the 9th, y to the 12th. So notice the 9 here is going to be the issue because 9 is not divisible by 2. 12 is, so that's going to be fine. This one won't. And notice 28 is not a perfect square either. Okay, so I'm going to rewrite this as the square root of 28 times the square root of x to the 9th times the square root of y to the 12th. All right, so just using the product rule. So what's the largest perfect square that goes into 28? The answer is 4. So that becomes the square root of 4 times 7. For this one, think our process. What's the largest number less than 9 that's divisible by 2? The answer is 8. So it becomes the square root of x to the 8th times x, right? And then this right here, that's easy now. So that's just going to become the square root of y to the 12. 12 divided by 2 is 6. It'll be y to the 6, because y to the 6 times itself is y to the 12. All right, now let's go ahead and rewrite this now. So it becomes the square root of 4 times the square root of 7 times the square root of x to the 8th times the square root of x times y to the 6. The square root of 4 is 2. The square root of 7. The square root of x to the 8th is x to the 4th. 8 divided by 2 is 4. Square root of x, y to the 6. All right, now remember our property right here. You have to use it. See this right here? I have a square root of 7 and the square root of x. So the indices are the same. So I can write this as a product of one radical instead of 2. So our answer is going to be, and we always put that at the end, so it'll be 2 x to the 4th, y to the 6th, times the square root of 7x. That's the answer. Okay? All right, so that is the key to, this worksheet.